Imagine you are falling, not the falling you know, the brief, stomach-lurching kind that ends in impact. This is something else. You are falling into the largest planet in the solar system, and there is no ground beneath you. Jupiter has no surface, and that single fact, that absence, is what makes this place more terrifying than anything else in our neighborhood of space. You are 600 million kilometers from Earth. No one is coming. At first, it is almost beautiful. From a distance, Jupiter looks like something out of a painting, amber and cream and rust, enormous bands of cloud wrapping around a world so large that 1,300 Earths could fit inside it. The Great Red Spot, that storm older than the United States, older than the telescope itself, churns silently below. There is something almost serene about its scale. Something that makes your own existence feel very small, very brief, very quiet. You enter the upper atmosphere at around 180,000 feet above the cloud tops. The sky here is pale and thin, hydrogen and helium mostly. The pressure is close to what you'd feel on Earth. The temperature is brutally cold, around minus 145 degrees Celsius. But you are still alive, still falling. For a few minutes, it almost feels survivable. Then the atmosphere wakes up. What most people don't realize is that Jupiter's clouds are not a single layer. They are stacked. Multiple decks of cloud, each one more violent than the last, each one a different kind of hostile. The first layer you enter is made of ammonia ice crystals. Visibility drops. Wind speeds exceed 600 kilometers per hour in the jet streams, faster than any storm ever recorded on Earth. You are not descending through weather. You are descending through a planetary engine. The turbulence is not the rattling kind you feel on an airplane. It is structural. It would disassemble you. But assume, for the sake of understanding what lies below, that you continue, that something is carrying you deeper. The deeper you fall, the warmer it gets. Pressure climbs. Every 100 kilometers downward adds another atmosphere of weight pressing against you from every direction. At around 50 kilometers below the cloud tops, the pressure is 10 times what you experience at sea level on Earth. The temperature has risen sharply. You are passing through a layer of water and ice clouds now. Warmer, wetter, stranger. This is where NASA's Galileo probe met its end in 1995. That probe was dropped intentionally into Jupiter, not as a rescue mission, not an experiment in survival, but as a controlled sacrifice. It had a heat shield. It had instruments. It had been designed by some of the brightest engineers on the planet specifically for this environment. It survived 57 minutes. It made it to about 160 kilometers below the cloud tops before the pressure reached 22 atmospheres and the temperature climbed past 150 degrees Celsius. Then it simply stopped transmitting. Not an explosion, not a dramatic failure. It was compressed into silence. You are still falling. The sky, if you can call it that, has turned dark amber. There is no sun here, no reference point, no horizon, just increasing pressure, increasing heat, and a column of atmosphere below you that extends for thousands of kilometers. The human body can tolerate, under extraordinary circumstances, about 3 to 5 atmospheres of pressure before the lungs collapse. You passed that threshold long before the Galileo probe stopped transmitting. But something else is happening too, something that most people don't consider when they picture falling into a gas giant. You cannot see it. You cannot feel it directly. But Jupiter's magnetic field, the most powerful of any planet in the solar system, is actively irradiating you. Its radiation belts are roughly 10,000 times stronger than Earth's Van Allen belts. The Juno spacecraft, which orbits Jupiter today, was built with a radiation-hardened vault to protect its instruments. Even so, every orbit degrades its electronics slightly. A human being without shielding would receive a lethal radiation dose not after months, not after days, within hours of entering Jupiter's radiation environment. You would be dying from the radiation before the pressure became relevant. The danger here doesn't wait for you to fall into it. It reaches out. This is where the scenario shifts. Everything so far has followed a predictable arc. Cold, then wind, then pressure, then heat, then radiation. A sequence of worsening conditions you can track, understand, almost prepare for mentally. But somewhere below 1,000 kilometers, the atmosphere begins to change in a way that has no analog anywhere in human experience. The hydrogen that makes up most of Jupiter's mass, begins to behave differently under extreme pressure. It stops acting like a gas. It starts behaving like a liquid. And then, deeper still, something happens that took physicists decades to accept as real. The hydrogen becomes metallic. It conducts electricity. It flows. It is no longer a substance we have a useful word for in everyday language. Metallic hydrogen exists in a state that does not occur anywhere on the surface of the Earth under any natural conditions. It is alien matter, and you are falling through it. There is no moment of impact, no surface to hit. The atmosphere simply becomes something denser, something stranger, something that consumes rather than stops. The transition from gas to liquid to metallic fluid is gradual, then absolute. This is what Jupiter is at its core. Not a planet you fall onto, but a planet you fall into. Endlessly, completely, without distinction between the falling and the arrival. At some depth, somewhere between 40,000 and 60,000 kilometers below the cloud tops, there may be a solid core. Scientists still debate this. It may be rocky. It may be a diffuse region of dense, hot material compressed beyond recognition. Temperatures near 35,000 degrees Celsius. Pressures 40 to 100 million times greater than Earth's atmosphere. Not molten, not solid in any familiar sense, just matter under conditions that erase the categories we use to describe matter. Nothing reaches it intact, not the Galileo probe, not a spacecraft, not an idea. Whatever you are at the top of Jupiter's atmosphere, you are not that by the time you reach the middle. And whatever remains by the middle does not reach the bottom. The planet consumes in layers, each one methodical, each one total, each one unremarkable in the way that only truly absolute things are unremarkable. There is no rescue scenario worth considering. The delta V required to slow a descent into Jupiter, to reverse it, to escape its gravity well from within the atmosphere. It exceeds anything humanity has ever built or currently imagined building. Even if a spacecraft could reach you, even if it could find you inside 600 kilometers per hour winds and zero visibility and lethal radiation, the physics of retrieval from inside a gas giant are not a challenge we are decades away from solving. They are a different category of problem entirely. You do not fall into Jupiter and return. You fall into Jupiter, and Jupiter continues. Here is what stays with you after everything. Jupiter has been doing this for 4.5 billion years, pulling things in, compressing them, erasing them, incorporating them silently into its mass. Comets, asteroids, the fragments of things that once were somewhere else. In 1994, comet Shoemaker-Levy 9 broke apart and struck Jupiter over 6 days. The impact sites were visible from Earth, scars larger than our entire planet. Jupiter absorbed them, continued its rotation, continued its storms. It did not notice. And that is the thought that lingers, not the pressure, not the radiation, not the alien physics of metallic hydrogen. It is the indifference, the absolute structural indifference of a system so large that human existence registers within it the way a single breath registers against the age of the universe. You were never falling into danger. You were falling into scale, and scale does not care.